Dear students, today taking a problem of engineering mechanics of the parallel force system. Parallel force system. This is a question. Question: A beam is loaded as shown in the diagram. Diagram is shown in the right side, and find the reaction at point A and B. So this is the problem. Here you can see that this is point A. At this point reaction RA is to be determined. At point B this is reaction RB is to be determined. Now on this beam AB there are three forces: 150 Newton at point C, 150 Newton at point D, and one uniformly distributed load UDL at 5 Newton per centimeter rate. This is shown in the diagram. So there are three loads: 50 Newton and this UDL and 50 Newton. These three forces are acting on the beam. All the three forces are parallel but acting vertically in downward direction and parallel. Now distances are also shown. From point A, 50 Newton force at point C is acting at 100 centimeter distance, and UDL is at a distance 140 centimeter from point A starting point, and ending point is at 280 centimeter from point A, and other distances are also shown. That D point is 100 centimeter from point B, and another end of the UDL is 20 centimeter from point D. So how to solve this problem? So you can see that in this figure, as shown in the diagram, uh, the system of parallel forces are shown, and first step is to change the UDL, uniformly distributed load, into point load. First what we will do? First we will change uniformly distributed load into a point load and find its point of action. And in the second step, write the equilibrium equations for the given forces in x direction and y direction. Here x direction is taken along the beam as shown in the diagram, and y direction perpendicular to the beam, normal to the beam, as shown at point A, y direction. So in second step we will write the equilibrium equation like sigma fx is equal to 0 and sigma fy is equal to 0 as shown here. This is the second step, we will discuss later. And so and in third step write the moment equation about point A, and point A about point A we will write the moment of forces and sum of the moment of forces, that is moment equation, we will write. And fourth step is to solve the equations and to determine the unknown reactions at point A and B. So step 1, we can see that there is a uniformly distributed load at 5 Newton per meter for a span of 140 centimeter. So this load uh, changed into the point load, that is 5 Newton per centimeter into 140 centimeter, as this is uniformly distributed, so 700 Newton. This will act at a point, and where it will act, suppose it will act at point E. At point E, position of point E is in the middle of the UDL means 70 centimeter from first end of the any end of the UDL. So this will be 100 centimeter plus 40 centimeter plus 70 centimeter from point A, and similarly 100 centimeter plus 20 centimeter plus 70 centimeter from point B. So this will come out as 200 centimeter plus 40 centimeter plus 70 is equal to 210 centimeter from point A, or 190 centimeter from point B. And the next step is to write the equilibrium equation. So sigma fx is equal to 0. In x direction there are no any force, and in y direction there are forces, three forces and two reactions. So we will write the equilibrium equation for them. So is in Ra and Rb are both in upward direction, positive y direction, and 50 Newton and 700 Newton and 50 Newton. These three forces acting at C, E and D, these are in negative y direction. So we are taking them as negative. So writing the equilibrium equation as Ra minus 50 minus 700 minus 50 plus Rb is equal to 0. And from this equation we get Ra plus Rb is equal to 800 Newton. This is the equation number 1, first equation. And then step 3 is to write the moment equation. Suppose suppose we are taking moment about point A, we can also take moment about point B. Also we can take moment about point P. So in this case we are taking moment about A. So moment about A. So here you can see in the diagram that 50 Newton will produce a moment, clockwise movement, 50 into 100 centimeter, perpendicular distance 100 centimeter about the point A, means this clockwise movement. So the clockwise movement is considered as negative. UDL, point load 700 Newton will also produce clockwise movement, and this 50 Newton will also produce clockwise movement. So all the three taken as negative. And RB, reaction in upward direction, this will produce anti-clockwise movement. So this is taken as positive. Here you can see minus, therefore these are minus sign are taken for clockwise movement. Minus 50 into 100 centimeter, minus 700 into 210, minus 50 into 300 plus RB into 400 is equal to 0. As RB has 400 centimeter distance from point A, perpendicular distance 400 centimeter. So solving this equation we get this as Rv is equal to 417.5 Newton, and putting this value in equation 1 we get Ra, value of Ra 800 minus Rb, and that is equal to Ra is equal to 382.5 Newton. So this is a simple problem of engineering mechanics of parallel force system. Now for similar problems you can uh, see our channel or contact me. Thank you.